We've already talked about the shape of robots, but more in relation to engineering, kinematics, and the like. Maybe you remember that we talked about link-based robots, typical robot arm, box-like robots, and even the special case of soft robots. But when we talk about shape in industrial robots, or even in most of service robots, the shape has everything to do with the function the robot plays. For example, industrial manipulators like arms is a good shape because that shape allows the robot to reach the necessary point in its workspace, the point where it has to act. In the case, for example, of last mile delivery robots, the box is a good shape because it allows the robot to have some cargo in it. In special cases where the robot has to move in an irregular land or field, we may use, for example, caterpillar tracks instead of wheels, or even legs, as happens in the case of dog robots, such as Spot from Boston Dynamics. But in the case of social robots and human-robot interaction, uh, shape is a different story. It plays a special role. In the case of social robots, we tend to have, let's say, three classes of shapes. We have humanoid or anthropomorphic robots, such as Sophia or Ameca or Pepper or 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 the so famous Optimus from Tesla. There are also zoomorphic robots that resemble animals, for example, the baby seal Paro, the pet dog Aibo, or the little dinosaur Leon. And sometimes it has abstract and minimal shapes, but with some basic relationship capabilities, such as we can find in robot Gibo. And the important thing is that shape determines the expectations we put on the robot, what sometimes are called affordances. For example, if you see a tactile screen on the robot, such as you can see in the case of Pepper, you assume that you can touch on it and get some action done. If we see a humanoid robot, you tend to expect that it behaves like a human and understands like a human. And if the robot speaks, we tend to assume that it also understands. And if the robot expresses emotion through gesture, for example, we assume unconsciously that the robot really feels. So shape is very important. And related to shape, and in the field of human-robot interaction, there are some design principles. First of it is match form and function in the design. For example, don't use a humanoid robot for a cleaning robot, to say something. Second principle, under promise and over deliver. Because if the shape suggests that the robot will do a lot of things and then the robot is more limited, we feel some kind of deception. So it's better not to design a shape that puts great expectations on the robot. Sometimes it's not even good to name the device as robot because we tend to set great expectations on robots. Third principle, related somehow to the previous one, is interaction expands function. What that means is that we humans tend to fill the gaps that there can be in the behavior of the robot. So it's better a simpler design. In the case, for example, of a robot to work as a pet, we have already mentioned several times the robot Pat, the baby seal. And as we usually don't expect very much from a baby seal, we don't expect that it moves very much and things like that. It's a good design to use a baby seal. If we, instead of a baby seal, created, for example, a cat or a dog, probably our expectations would be greater. But we design a baby seal, and the human fills the gap and recognizes that robot really as a pet. And finally, the fourth principle is don't mix metaphors because it suggests strange things and expectations get also mixed. For example, in the case of a zoomorphic robot, don't make that zoomorphic robot to speak or to talk like a human would do because it's somehow strange. Or if we are talking about a high fidelity humanoid robot, it's supposed that it's not good that it is only partially covered by skin. It should be completely covered by skin. Finally, there are two interesting phenomena related to shape. First one is what is called uncanny valley, and not really demonstrated theory, and not everyone agrees with it, but it's an interesting one, and it states that the more human-like a robot is, the more likable is the robot for us humans. But that applies to a certain point, because when the robot becomes almost undistinguishable from humans, and at that point, the likability of the robot decreases dramatically. And it's not only that we do not like the robot, it's that we reject it. And finally, there's another phenomenon, what is called anthropomorphization. Anthropomorphization is the fact that we humans tend to assume human traits on different things, on objects, on toys, or wherever. But in the case of humanoid robots and social humanoid robots, its shapes and its relational capabilities stress this phenomenon. But anthropomorphization is a very important phenomenon in the area of ethics, so we will speak about it in a completely different video.